friends. In this video I'd like to solve the following problem from the Brazilian Mathematical Olympiad, university level, first round, year 2019, problem number 21. We wish to evaluate the following definite integral from 0 to pi over 2 of t sine 2t over 1 plus cosine squared of 2t dt. So my hints for this problem. First, consider changing t to pi over 2 minus u to express our integral in two different ways. Then remember these two well-known trigonometric identities. Cosine of pi over pi minus alpha is minus cosine of alpha, and sine of pi minus alpha is sine of alpha. And finally, remember that integral of dv over 1 plus v squared is just arctangent of v plus some constant. So give this problem a try and I will see you in a minute. Okay, so here comes my solution. First, I will call my integral, let's say I, let I be this integral, and I will make the following change of variables. T equals pi over 2 minus u. What happens then? Then dt is just minus du, and our bounds of integration, original bounds were from 0 to pi over 2, and they become from pi over 2 to 0. So our integral can be written in the following way. It goes integral from pi over 2 to 0. Instead of t, I have pi over 2 minus u, sine of 2 times pi over 2 minus u, 1 plus cosine squared 2 pi over 2 minus u minus du. Okay. And what next? Well, first I will take this minus standing next to du to change bounds of integration from 0 to pi over 2. And I have pi over 2 minus u, sine of pi minus 2 times u, 1 plus cosine squared of pi minus 2 times u du. And now, let's see. Here I have pi over 2 minus u, using a well-known identity for sine of pi minus something, which I hinted at. It's sine of 2 times u, and in the denominator I have cosine squared, again of 2 times u. Well, it's minus cosine of 2 times u, but we have a square, so minus vanishes. And remember that that is just a number. So the name of a variable doesn't really matter. So I can change back from u to t. Okay, very well. And remember also, at the same time, the very same integral was just integral from 0 to pi over 2 of t sine of 2t 1 plus cosine squared of 2 times t dt. So we have two ways of expressing the very same integral. And what I suggest doing is, by noticing that this part is exactly the same as this part, I suggest adding these two integrals together. So let's call that it is, here we have asterisk, here we have double asterisk, by conditions asterisk and double asterisk, we have the following. 2 times our integral equals integral from 0 to pi over 2. And what happens after our addition? Let's take a look. Here we have t, and here we have pi over 2 minus t. So after adding these things, I will get just pi over 2. And pi over 2 is just a constant, so we can put it in front of our integral. Okay, very well. And now it's time to do another substitution. So now I will substitute. I will put v, for example, v to be cosine of 2 times t. Is it legal? Yes, it is, because our integral goes from 0 to pi over 2, and we know that cosine is a differentiable bijection on the interval from 0 to pi. So it's legal, perfectly legal. dv becomes minus 2 sine of 2 times t dt, which means that sine of 2t dt, it's just minus 1/2 dv. And finally, what happens to the bounds of integration? Well, t goes from 0 to pi over 2, and that means that v, cosine of 0 is 1, cosine of pi is minus 1. So we have integral from 1 to minus 1. So that means that 2 times our integral equals pi over 2 integral from 1 to minus 1. Instead of sine 2 times t dt, I can put minus 1/2 dv over 1 plus v squared. Very well. And now what can I do? Well, I can take this minus right here to change the bounds of integration. I can also put 1/2 in front, so I have pi over 4 integral from minus 1 to 1 dv 1 plus v squared. And as we know, this integral is just arctangent pi over 4 times arctangent of v evaluated from minus 1 to 1. And now remember that arctangent of 1 is pi over 4. I'm sorry, there should be pi over 4 here. So we have arctangent of 1 is pi over 4, and arctangent of minus 1 is minus pi over 4. So that is pi over 2. Pi over 4 times pi over 2 is pi squared over 8. And that was twice our integral, which means that maybe I will put everything a bit higher to fit my answer. And that means that I, which was our integral, equals pi squared over 16. And that is our answer. So yes, thank you for watching, and I will see you next time. Goodbye.